We are starting Poisson distribution. Already we have learned some basics and solved one example. So I'm going to restart it. Here's the book. I hope you can see the book. Okay. Hello.
Yes, sir.
Yes.
Look at this. They're totally application based. Can you remember the floppy disk? Like in some tape. A USB flash drive, that is a floppy disk, is sometimes used to back up the computer files. However, in the past, a less reliable backup system, sorry, this is the USB flash drive now using, and in past, a less reliable backup system was used in a computer tab. It was actually floppy disk. And flaws occurred in these tabs. Flaws mean bad sectors where data cannot be read. Okay, sometimes there are some but bad sectors. At those points, data can be lost or non-readable. In a particular situation, flaws, that is a bad records or bad sectors on a used computer tab occurred on average. On average, that is usual. One flaw for 1200 feet. So, how many flaws in 1200 feet?
One floor.
One flaw. It is assumes if one assumes a Poisson distribution, what is the distribution of x? That is the PMF. The number of flaws in 4,800 feet roll. Now, first we have to find lambda. We know lambda equal to NP. But what is N? What is P? N is the total resource. It has been given there are total 4,800 feet roll. This is the resource. And P, probability of getting the flaws, it has been said that out of 1200 feet there is one flaw. So at 1 feet there is how many flaws? So lambda is a multiple of this, we will get 4. Do you understand how we get the lambda?
Yes, sir.
Yes.
So fx will be 4 to the power x e to the power minus 4 x factorial. Now you can ask me how this is a Poisson process or Poisson distribution. Though here we got in this tab on average 4 flaws may occur, but with the increasing of time the flaw will increase. Once a time it will be 10, then 20, then 100. Once a time you can find the computer tab totally non-readable. That is, full computer tab are full of flaws. একসময় কি হবে? পুরোটাই ফ্লতে ভরে যাবে না?
Yes, sir.
That's why the number of flaws tends to infinity. Okay. So it is called, since it may happen infinite time, so this is the Poisson distribution or Poisson process. Now, in particular, x is 0, that is there is no flaw, there is no bad sector. So put x equal to 0, put it by 0 to the power minus 4 by 0 factorial, you will get this. And if x less than equal 4, if x less than equal 4, then x less than equal 4 means what? It has started from x equal to 0 up to what? x equal to 4. So how many values we have to take? How many
5.
values? 5 values. Right. Put x equal to 0, 1, 2, 3, 4 and add them. You will get the desired result, which is this. That is, finding lambda is the main concept of this chapter. You can find another math. In a large city, telephone calls to 911. 911 is the emergency number. Come on average of 2 every 3 minutes. If one assumes an appropriate question process, what is the probability of 5 or more calls arrive in a 9-minute period? Usually it comes 2 every 3 minutes. So probability of getting the call 2 every 3 minutes. And we have resources 9 minutes. What is our resource? 9 minutes. So what is the average time? This is 6. Average time is 6. Average calls within the 9-minute period is 6. So you can write fx, that is the PMF, is equal to e to the power minus 6, 6 to the power x, x factorial, whereas x equal to 0, 1, 2 and so on. Do you understand?
Yes, sir.
What they asked? They said, what is the probability of 5 or more calls? So 5 or more calls means what? X greater than equal 5. X greater than equal 5. Now I have said, or you can see, x minimum value is 0, maximum value is unknown. So you cannot complete this with greater than equal or greater than relation. So we have to use the complement. 1 minus p of x equal to 4. So 1 minus this x equal to 0 to 4 as like before. Putting there, after summing you will get this, and after the simplification the probability of x greater than equal 5 is 0.715. Do you understand?
Yes.
Yes, sir.
So you have to carefully find the lambda, then it will be easier. Okay. Then we'll find if n is sufficiently small, not very large, and p is also reliable, that is not very close to 0. In that case, the Poisson distribution and binomial distribution gives very close probability. That gives the probability is very close. Like one, we have to complete this. A manufacturer of Christmas tree light bulbs knows that 2% of the bulbs are defective. So probability of defectiveness is 0.202. Defectiveness, assuming independence, the number of defective bulbs of 100 bulbs has a binomial distribution. That is, first we will consider the binomial distribution. So n is 100. So definitely you can write q equal to 0.98. So for binomial distribution we'll get the PMF is fx 100 cx 0.02 to the power x 0.98 to the power 100 minus 6. Once again, we have to take this for Poisson distribution. For Poisson distribution, lambda equal to np, so it will be 2. So for the Poisson distribution, you will get 2 to the power x or e to the power minus 2, 2 to the power x by x factorial. Okay, we get the PMF for both of the binomial and Poisson distribution. as per they have said. Now, here we have to find the probability. They have found the probability x less than equal 3, that is at most 3, using the Poisson distribution. Also, they found the x less than equal 3 for the binomial distribution. You can see they're very close. What's this? The distributions, the distribution value, that is the probability value, very close. Okay.
Yes, sir.
So what can we assume? If the number of n is not very large and probability is not ignorable, that is not very close to 0, in this situation, the probability gained by binomial distribution and Poisson distribution will be very close. What is we have seen. So in this chapter, you have to study example 1, 3, 4, 5. 1, 3, 4, 5. Now exercise. We'll do 1, 2, 3, 4, 5, 6, and 8. So 1 to 6 and 8. Okay.
Hello.
So let us start the exercise. One is homework, because very straightforward. Here given the Poisson distribution with mean 4. If mean 4, then we have the probability. What is the probability? Fx is probability distribution mass function PMF is e to the power minus 4 4 to the power x by x factorial, whereas x equal to 1, 2, 3, and so on. And this is very simple. The first one is probability 2 to 5. Just add x equal to 2 up to x equal to 2, 3, 4 after x equal to 5. Just find the probabilities and take the sum. This is probability greater than or equal to 3. It's actually, as far as I have said, you cannot consider the probability greater than or equal condition for Poisson distribution. You have to write this 1 minus p of x less than or equal to 2. So you have to write 1 minus p of x equal to 0 to what? This is the answer. Okay. Finally, p of x less than or equal to it will be what? P of x equal to 0, p of x equal to 1, p of x equal to 2, p of x equal to 3. But I can give you a suggestion. Since you have to find 0 to 5 actually, how many values you need? 0 to 5, because here 0 to 3, here 0 to 2, here 2 to 5. So if you consider first x equal to 0 to 5, 6 values you can calculate, then you can put there. আগে তোমার 0 থেকে 6 পর্যন্ত probability find out করে রাখবা, then এখানে কি করবা? তাহলে বারবার ক্যালকুলেট
ভ্যালুগুলো
করার
বসিয়ে
দরকার
দিব।
নেই। তাহলে সুবিধা কি হবে? You need to calculate them multiple times. So first calculate from x equals 0 to x equal to 5, then put them where I have written. Do you understand?
Yes, sir.
Simple task. Then number 2, let x have a Poisson distribution with variance 3. Variance 3, then p of x equal to 2. Simple. Say 2. They're given, we know x equal to this equal to 3 here, because in case of the Poisson distribution the mean and variance are same. Then fx is e to the power minus 3 is to the power x by x factorial.
Sir, lambda equal to 6 square.
No, sigma
Okay.
square. X equal to 0, 1, 2 and so on. This is sigma sign. Then p of x equal to 2 is e to the power minus 3 square by 2 factorial. After simplifying, you will get 0.224. Then number 3, customer arrive at a travel agency at a mean rate 11 per hour. That is lambda is 11. Assuming that number of arrivals per hour has a Poisson distribution, give the probability that more than 10 customers arrive in a given hour. Concept is easy, but math is lengthy here, because it has been said that lambda is 11. So fx will be e to the power minus 11 to the power x by x factorial. Now it has been said customer arriving in an hour greater than 10. So 1 minus p of what? X less than equal 10, right? So what should we do? We have to find 1 minus, actually from x equal to 0 to 10, e to the power minus 11 to the power x by x factorial. Actually it's tough, because you have to calculate how many probabilities?
11.
How many? 11. So after completing this, you'll get 0.46, that is 0.54. But one positive thing I want to say, in your exam you'll get at most 5 values, not more than 5. So don't be panicked. This one is given in the book, but I will not give such a lengthy math in your exam. Okay.
Thank you, sir.
Then number 4, they have said, they have given a condition 3, probability of x equal to 1 is equal to p x equal to 2. If then you have to find probability p of x equal to, let me check, x equal to 4. This is our requirement. This is the requirement. That is, from the given condition we have to find lambda. Using lambda we can find the PMF, and then using PMF we can find p of x equal to 4. Now given y, we can write 3 as e to the power minus lambda. We don't know what is the lambda. Lambda power 1 divided by 1 factorial is equal to e to the power minus lambda square by 2 factorial. Now we can cancel e to the power lambda from both of the sides. We will get 3 lambda by lambda square by 2. because e to the power minus lambda not equal to 0. Then we'll get lambda square equal to 6 lambda. That is lambda equal to 6. Why lambda equal to 6? Lambda not equal to 0. So from both sides you can cancel the lambda. So what is the average here? 6. What is the average?
6.
6. Since lambda equal to 6, fx is e to the power minus 6, 6 to the power x by x factorial. Then we have to find f x equal to 4. What is x equal to 4? E to the power minus 6, 6 to the power 4 by 4 factorial. After calculation, we get 0.1338. Do you understand?
Yes, sir.
So then 5 and 6 are same. Do 5 as homework. I am doing 6 for you. It has been said that a certain type of aluminum screen 2 feet wide has on average 1 flaw in 100-foot roll. Find the probability of 50-foot roll. Has no flaws. Okay. Similarly, it is actually same. Flaws in a certain type of drapery material appear on average 1 in 150 square feet. I am giving instruction for number 5. Here they said P equal to 1 by 150 and N is given as 225 square feet. So lambda will be 3 by 2. This is for 5, okay. Lambda will, so put them, you'll get fx, and they ask for at most 1. At most 1 means x less than equal to 1. So you have to find what? X equal to 0 and x equal to what? 1. Okay.
1.
Main information are given here. You should follow them to find the result. But same thing occurs here. The certain type of aluminum screen that has 2 feet wide on average, 1 flaw in 100-feet roll. You can see wide is 2 feet, but is moving to the length. So 2 feet will have no effect on your calculation because this is the wide only, but we are considering on the length. Okay, so 2 feet have no impact on our calculation. Do you understand?
Yes, sir.
It has said that 1 flaw in 100 feet. 1 flaw in 100 feet. Number 6. So on average, in a feet, 1 by 100 flaws, and our resource N is 50 feet. So the lambda is NP is equal to half. Then fx is e to the power minus half to the power x by x factorial. Now they asked for saying that in this length there is no flaw. So e to the power minus half to the power 0 by 0 factorial. Using a calculator, you will get 0.606. Okay. বুঝতে পেরেছো?
Yes, sir.
Now 8. Suppose that the probability of suffering a side effect from a certain flu vaccine is this. This is the probability of getting the side effect. So this is P. P is 0.005. And if 1,000 persons are inoculated, they're affected. We're considering 1,000 people, so this is N. Then find the following. Now, one thing. You can get N and P, but we are not using the binomial distribution, but we will use the Poisson distribution to find the probability at most one suffers, 4, 5, 6 persons suffer. But why we are using the Poisson distribution but not the binomial distribution? Any idea? What is your idea? Why we are using it? Hello?
Yes, sir.
Why we are using the Poisson but not the binomial? Any idea?
No, sir.
Okay. Number one, for the binomial distribution, there must be the word assuming independence. But here, independence not has been given. Okay. Independence not given. That is the main reason. So for binomial distribution, you must find the word independence, which is absent here. Now, P is 0.005, N is the 1,000. So lambda equal to NP is 5. That is fx is e to the power minus 5 to the power x factorial. The first question is probability of this is at most 1. So this. So P of x equal to 0 plus x equal to 1. You can write here e to the power minus 5 to the power 0 by 0 factorial plus e to the power minus 5 to the power 1 by 1 factorial. After completing the simplification, you will get 0.404. And finally, as I said, you can see the probability of 4, 5, or 6 person. 4, 5, 6 person. So this is actually OR relation. That is 4 less than equal x less than equal 6. So in probability, this is probability x equal to 4, x equal to 5, and x equal to 6. In a similar manner, you can consider them, and after summing, you'll get 0.497. Do you understand? Have you any question on Poisson distribution?
No, sir.
So lambda will play the key role in this kind of math. If you can find the lambda, the rest of the math is easy. If you have no problem, then I will go to the next chapter. I will start the continuous distribution. So I'm closing this. Continuous distribution is actually, we have already said what is the discrete distribution or what is the continuous distribution. A discrete distribution take the random value of the random variable which can be counted. That is 1, 2, 3. They can be counted. They can be counted. That is the counting number will have the input. But sometimes you cannot take the numbers at a whole. That is, we cannot count them like 1, 2, 3. But we can say the values lie between A to B. Say lie between 3 to 7. Say lie between 0 to 2. That is, instead the values you will get some. Instead the values you will get some interval. What you get?
Intervals.
Intervals. Otherwise, all other properties will remain same. This is like this. You can see you cannot count now A, B. You cannot count the values, but you can see the values within A to B. Like this. You cannot count X, but you can say X between A to B. So this kind of variables are called the continuous type variables. Now I'll show some basic properties of the continuous variables. I'm starting with very important one. In the previous chapters, we have seen, say x less than or equal 4. We can consider like less than or equal 4, that is 0 to 4, right?
Yes, sir.
0 to 4. It was say x less than 4. Less than 4 means what? Less than or equal 3, right? Less than 4, that means less than or equal 3. Okay, because the number is counting. They are discrete. So before 4, it's what? 3. All right.
Yes, sir.
This is for discrete values. But in case of continuous values, another thing I want to show. Say any value x greater than 7. You cannot write actually this. You have to write 1 minus. If I take this greater than or equal 7, I write x less than or equal 6. That is a basic rule for the discrete type. But in case of continuous type, say I want to write x greater than or equal 7, I write 1 minus x less than 7. Now you can ask me why 7 in both sense. Actually, in case of discrete, before 7, this is 6. But in case of continuous type, before 7, this is not exactly 6. Since this is a continuous, it can be 6.5. This can be 6.9. It can be 6.99, 6.999, 6.9999. That is, it is very close to 7. Am I right?
Yes, sir.
Hello?
আপনার কানেকশন মেবি চলে গিয়েছিল।
Yes. Now can you see the presentation?
জি স্যার, দেখা যাচ্ছে। এখন আবার চলে গেছে।
Okay, I'm Okay, one second. Okay. So in case of continuous type, before 7, not 6 exactly. Before 7, you can consider 6.9. Before 7, we can consider 6.99. Before 7, we can consider 6.999, which is very close to 7, right? Okay.
Yes, sir.
So in case of the continuous type, for x greater than equal 7 and greater than 7, we will take the same thing, because greater than equal 7 and greater than 7 may have difference 0.00001, very small difference. So we can ignore this difference. This is one of the main difference between the continuous and discrete type, because discrete means one after one, but continuous means very close. Okay. This is the first case. Second case, in case of the discrete distribution, we have considered the sum for taking multiple probabilities, right? What we have considered? Sum. Say x between 0 to 2. We have summed x equal to 0, x equal to 1, x equal to 2, right?
Yes, sir.
But now we will not do this. We will take the integration. This is the continuous interval. That's why we will take the integration instead of the sum. Fx was said PMF, but now in continuous type we'll say them PDF. PDF, probability density function, not probability mass function. This is probability density function. Okay. This is now what?
Probability density function.
Probability density function.
Also the CDF Fx, which was the sum of, now it will be minus infinity to x. We have to use a dummy variable, say FW or DW. Now this is the CDF. You can see instead sum we are using the integration, not using the sum right now. This is now what? Integration. Okay.
Yes, sir.
Another thing, you may confuse with the notation minus infinity, but please don't do this. Actually, minus infinity means the lower limit of the given interval. If our lower limit is 1, we'll put 1 instead of minus infinity. This is a symbolic minus infinity, not exactly minus infinity. Say our limit is given, a less than equal x less than equal b. You can see I am using an interval, not some values. In this case, fx will be a to x fw dw. Do you understand?
Yes, sir.
Before entering to the book, I am going to show the first distribution of the continuous type is called a uniform distribution. Uniform distribution is denoted by UAV. UAV, it is uniform distribution defined between A to V, which is represented by Fx is equal to 1 by B minus A, where A less than equal X less than equal B. This is called a uniform distribution. You can see for all values of X, there is a constant probability. We have studied the uniform distribution in a discrete type in chapter 2.1. Now here, this is another uniform distribution, but in continuous type. We'll make sure that the total probability is 1. So we have to take the not sum. Now what? Integration. Okay. We're not considering the sum. What is considering now?
Integration.
So 1 by b minus a x, then we'll get 1 by b minus a into b minus a. So what is this? 1. So what is the total probability?
1.
1. So uniform distribution actually is a distribution at every point of the given interval, they have the same probability. And we have seen total probability is 1, so this is a valid PDF. The PDF is valid now. Since we got this, we need to find the CDF now, probability cumulative distribution function. You know, CDF. Two things will remain same. CDF is fx is 0 before entering the set. We know this, right? And 1 after completing the set. Now in between we have to take the sum, but here in between this we have to take the integration. What is the integration? Integration is minimum value to x, what I have said, right? 1 by bwa dummy variable dw. What we find? 1 by b minus a x, not x, w a to x. So what? X minus a divided by b minus a. So it will be x minus a divided by b minus a for a less than equal x less than b. Do you understand? This is how we can find the CDF. That is before entering the given interval 0, after completing the given interval 1, and in between the interval we have to find using the formula what I have said here. Do you understand? Hello?
Yes, sir.
So we got PDF, we have verified this is PDF, we got CDF. Then we'll try to moment generative function. MGF, moment generative function. So MT is equal to, we know, expectation of e to the tx. So usually we know this is sum, but in case of the continuous type, this is integral. It would be e to the tx fx dx. Fx is b minus a dx. I'm doing those here because this is not given in the book. So 1 by b minus a actually constant. So 1 by b minus a. If you integrate e to the tx with the x, there is a t. Limit a to b. Okay. So e to the power bt minus e to the power at by t into b minus a. But you can see t not equal to 0. Why? Why? If t equal to 0, then it will be undefined. If t equal to 0, what will happen?
It will be undefined.
It will be undefined. So we have to find m0 differently, in a different approach. If we consider m0, here we can put m0. So e to the power 0, e to the power 0 is 1. So we'll find a to b e to the power 0 1 by b minus a dx, which will give us e to the power 0 is 1 by b minus a x b a. So b minus a by b minus a equal to 1. That is m0 is separately 1. So the moment generative function can be written as e to the power bt minus e to the power at divided by t of b minus a, but the condition is t not equal to 0, and this is 1 for t equal to 0. Here at t equal to 0, this is 1, so by default it has been verified. You need to verify this once again. We have found three things: PDF, CDF, MGF. Now we need mean and variance. So I am taking the expectation. Expectation of x is integration of a to b x fx. Fx is 1 by b minus a dx. Then you will find 1 by b minus a x square by 2 a to b. Okay. Then 1 by 2 b minus a b square minus a square. Can I write it here? X square. After simplification, b plus a into b minus a. B minus a cancel. So b plus a by 2. Okay. You can write a plus b by 2. Clear?
Yes, sir.
Now expectation of x square. What is the expectation of x square? Like once again a to b, but now x square fx 1 by b minus a dx. Then we will find 1 by b minus a x cube by 3 a to b. Then 1 by 3 b minus a b cube minus a cube. Then we can use b cube minus a cube equal to b minus a into b square plus ab plus a square divided by 3, or a square plus ab plus b square by 3. Okay. So we got the things. Then mu equal to expectation of x is equal to a plus b by 2, and the variance sigma square is equal to expectation of x square minus expectation of x whole square, and after simplification of those elements, you get b minus a whole square by 12. Okay. So we got total 5 things. How many things?
5 things.
5 things. The PDF, CDF, MGF, mean, variance. Do you understand?
Yes, sir.
Actually, I have derived them. I will provide this in our group. I have derived that because these things are not given in your book. That is, proofs are not given in your book. Now I am going to the book. Here you can see the PDF, the CDF are given for the uniform distribution, but they don't say it why, how you can find them. Okay. Also, you can find the probability of the uniform distribution, but if you put them PDF, a to b is 1 minus b minus a. You can see a to b, say this is a, this is b. A to b, this is 1 minus b, 1 by b minus a, this is a constant. Since a and b are constant, 1 by b minus a is also constant. Before entering the set, this is 0, and after this is 0 for PDF. And CDF, before entering this is 0, after completing this is 1, and within this, within a to b, there is a linear relation. Can you see the power of x is 1, right? What is the power of x?
1.
1. If power of x is 1, this is a linear relation. So this is the linear relation. This is a line. So these are the graph of the PDF and CDF. So in case of PDF, within a given set, the probability will be non-zero, and outside of the set or interval, the probability is 0. But in case of CDF, this is PDF fx. In case of CDF, before entering set, this is 0. After completing the set or interval 1, and in between, we have to see the power of x. If the power is 1, then it will linear. If power is 2, then it will parabolic, and so on. There, as usual, as a continuous type, discrete type, just the differences will use integration in case instead the sum, but everything will remain the same like as the discrete type. Then you can see the mean, variance, and moment generation function what I have derived given here. Before going to example 1, I want to show example 2, because example 2 is very similar to this. We can see, let x have a PDF, fx is 1 by 100, x between 0 to 100. You can write this as 1 by, what can you write? 1 by 100 minus 0, right? So a is 0 and b is what? 100. Okay. Hello.
Yes, sir.
So the mean, a plus b by 2, 50, and variance, b minus a whole square by 12. This is. Since we have the PMF, we can find the CDF also. CDF is fx, as per I have said. Before entering the given interval, it will 0. So x less than 0 is 0. And after completing the interval, this is 1. So for x greater than or equal 100, this is 1. And in between x minus a, x minus a, x minus 0, divided by b minus a is 100. If 0 less than or equal x less than 100. Do you understand?
Yes, sir.
Then MGF. MGF is empty. MGF is e to power bt, so e to power 100t minus e to power 80. A is 0, so 1. Divided by b minus a into t. B minus a is 100, so 100t. If t not equal to 0, and 1 if t equal to 0. So we have used all 5 properties. This is the PDF, this is CDF, MGF, mean, variance. Also, you can find the standard deviation. Do you understand?
Yes, sir.
Then I'm going to example 1, because example 1 and 3 for the same math. That is, 3 is in continuation of example 1. Look at this. Let y be the continuous random variable of PDF. Here PDF is given twice y. And the interval is 0 to 1. So lower limit is 0, upper limit is 1. That's why before entering the given interval, it is 0. And after completing the interval, this is what? 1. And within the given interval, lower limit to y, the dummy variable is now t. I have taken w, they have taken t. There is no problem. 0 to y, dummy variable twice t. From here, twice y, twice t dt. After integration, you will get what is this? 0 to y, 2t dt. So actually t square, 0 to y, So y square. You understand how y square here?
Yes, sir.
So before the interval 0, after the interval 1, and within the interval, this is y square. And one thing I want to say, in case of continuous distribution, you cannot find the probability directly. You have to use the CDF. Here's the CDF. A small letter will be converted to capital letter for the CDF. This is GY, small GY as the PDF, so capital GY as the CDF. Now you can see the interval given from 0 to 1, 0 to 1. And between 0 to 1, you can see what is the PDF? Twice y. This is line, right? Twice y is a line.
Line.
So there is a line between 0 to 1. You can extend before 0, it is 0, and after 0, this is also 0. But not necessary. You can show, but not mandatory. But in case of CDF, before entering the set, this is 1, this is 0. You can see before entering the set, this is 0. And after completing the interval, this is 1. After completing the interval, this is what? 1. And within the interval, this is y square, which is quadratic. So y square has this form. Do you understand?
Yes, sir.
So always before this 0, after this 1, and within this, we'll see what we get. So this is the graph of PDF and CDF. Then the probabilities. As we have the CDF, we will use the CDF to find the probability. So the probability between half to 3/4, as per I have said, in case of continuous type, less than and less than equal same. So we can write CDF of 3/4 minus CDF of half. 3/4 and half both lie in this section. You can see 3/4 and half both lie in this section. Am I right? This portion. So it will take, what is the function? Y square. What is the function?
Y square.
Y square. So 3/4 whole square minus half square. After completion, you will get this. Then probability 1/4 less than equal to y less than 2. So g of 2 minus 1/4. Now 1/4 within the set, so it is 1/4 whole square. But 2 is outside of the interval, right? 2 is where? Already the interval is completed. Am I right?
Yes, sir.
So outside of the interval, what is the CDF? CDF value? After completing this is 1, right? It doesn't matter what is value, the 5 or 10 or 20. This is more than 1, so its probability is 1. Can you see? The probability is directly written as 1. Okay. Now, if I take minus 1 less than y less than equal 1/3, so I can write z of 1/3 minus z of what? Minus 1. So 1/3 within the given interval, so 1/3 whole square minus z of minus 1. Z of minus 1 before 0, right? Here? Before 0. Am I right?
Yes, sir.
So its probability is what?
0.
0. So you can see, if you know the CDF, it's very easy to find the probability in case of continuous type. Clear?
Yes, sir.
Okay. I'll show this in an exercise. So I'm leaving this now. Mu variance, how can we get this also given here? Then continuing the same math. What is the expectation? expression y is y zy, but zy is twice y. They are given zy is what? Y square for x 0 less than y less than 1. Okay. So 0 to 1 y zy dy. You can see 2y square after integration 2 by 3 y cube. You can put the limit 1 to 0, you get it. Then variance. We know variance expression y square minus expression y whole square. They have written directly. So what is expression y square? Y square to y square dy. Y square for this y square, and this is the gy. That is the PDF dy. So actually 2y cube after integration 2 y to the power 4 by 4. So half y to the power 4. You can put the limit 1. You will get half. Half minus 4 by 9 is 1 by 18. You understand?
Yes, sir.
So this formula for mean and variance also valid here, but in case of sum, we have to use the integration. Nothing different. Okay.
Yes, sir.
Now there are 3 hard maths, continuous hard maths. They have said x has the PDF x e to the power minus x between 0 to infinity and 0 otherwise. We have to find moment generated function. Then using the moment generated function, mean and variance. So what is the moment generated function? We know e to the power tx fx dx. Given interval 0 to infinity, you can see the given interval is what?
0 to infinity.
0 to infinity. E to the power tx is from the basic form of moment generated function. This is fx dx. Now, how can we write it and why we should write it? Here you can see e to the power tx. We are taking x outside of this, e to the power minus x. Now we can write x as common factor. So what can I write? I can write by this, right?
Yes, sir.
Now, what is the problem? The problem is that if I take now x tends to infinity, what will happen? If I take x tends to infinity, then the whole term tends to what?
Infinity.
Infinity. That is, it cannot be converged. এটা converge করবে না। But converge যদি না করে তাহলে তো আমার moment generated function valid হবে না। Moment generated function valid হওয়ার জন্য অবশ্যই কি করতে হবে? Converge করতে হবে। কি করতে হবে?
Converse করতে হবে।
So, if I write in this way, x e to the power minus x, now I have to write 1 minus t. Now, if I take x tends to infinity, it will be e to the power minus infinity, which is 0. E to the power minus infinity is what?
0.
0. Now it converging. But if I consider this, it must be positive. Otherwise, once again, it will be disturbing because minus minus will once again plus. So 1 minus t must be positive. So t must less to 1. Now, as x tends to infinity, e2 tends to 0, converging. That's why this sign is taking, not this. এই জন্য এইভাবে নেওয়া হয়েছে, এইভাবে নয়। বুঝতে পেরেছো? But t is very important. You must take t less than 1. If t greater than 1, it will be negative. Then negative, negative, once again what?
Positive.
Positive. So don't do this. Always consider t less than 1 unit. In this case, we can write it. That's why this is. Now, using the properties of the improper integral, we know we cannot put the infinite limit directly. We are taking b instead of infinity, and b tends to infinity. Can you write it? We are taking b for infinity, whereas b tends to infinity. Same thing, right? Then solve this using the UV method. Okay, UV method, this is the integral value. Now if you put b x equal to b, you will get this, and if you put x equal to 0, first time vanish automatically and second term will come like here. Then as per I have said, if b tends to infinity, both the part are 0, right? If I take the infinity, b tends to infinity, both of the parts will what?
0.
0. Only this part will exist. So this is the final result. Now you can verify whether this is correct or not. Put t equal to 0. So 1 by 1 equal to 1. So this is a valid moment generative function. Now differentiate this first time, you'll get this. Second time, you'll get this. Then put t equal to 0. T equal to 0 will get 2 is the mean. And once again, t equal to 0 in both of them, I'm putting here, you will get variance also 0. So we find both the mean and variance are what?
Same.
Same. They are 2. I'm giving warning to you. This line, try this at home, because if you not try this at home, you cannot complete this in exam, because UV method is not easy here. UV method is not easy here. Oh, I want to give you one suggestion. You can use the tabular method. See chapter 7.4 in Anton book, Anton Calculus book. You will find how you take the UV method. 7.2 was sorry, 7.2, not 7.4, 7.2. There is a tabular method given. You can use the tabular method. Also, be careful about the differentiation, because there are 2 types. This is not 1 by t. After differentiating 1 by t square, you have to differentiate 1 minus t once again, because this is not t directly. Okay. So this is not as easy what you see seeing this. তুমি এখানে যা দেখছো এত সহজে কিন্তু এগুলো চলে আসে না, এটা নিজে নিজে বাসায় করবা। বুঝতে পেরেছো?
Yes, sir.
Now, till now we are finding the probability function, giving the input, and we get the probabilities. আমরা এতক্ষণ কি পাচ্ছিলাম? আমাদের probability ফাংশন গুলো ছিল, আমরা ইনপুট দিয়েছি, আমরা আউটপুট পেয়ে গিয়েছি, তাই না?
Yes,
But what will happen if probabilities are given? You have to find the input. That is the reverse way. That is, say fx is a function, as any function within an interval, say a less than equal x less than equal b. There is within an interval you have fx. Okay. Now you can find fx. How can you find fx? How can you find fx? A2 x ft or fw dw. Okay. By this you can find what? Can you hear me?
Yes, sir.
Say it has been said that the probability of any input phi p is a value whose probability is p. Phi p is a value whose probability is p. You have to find this phi p. It's our target. That is, now probability is not target. Input is the target. Then you have to write p of phi p is equal to p. Then definitely you have the function. That is, put x equal to pi p in this function, and solving this you have to find what? This value. This is the reverse way. This is what?
Reverse way.
Reverse way. I'll show with an example, by an example. But before that, I want to say some percentile, some things. Percentile, decile, quartile, and median. These are some positions of probabilities. Percentile means every hundreds. So 10 percentile. 10 percentile means what? 10%. What is the probability of 10%? What is the probability of 10%? 0.1. Say it says 27th percentile. So 27th percentile, what is the probability of 27th percentile?
0.27.
0.27. So if I say this is 27 percentile, find it. That is, you have to put here p equal to 0.27 and you have to find this position. Do you understand?
Yes, sir.
Like decile. Decile, that means every 10% is called a decile. So first decile, that means 10%. Second decile, that means 20%. So what is the third decile?
0.3.
0.3, because 0.3 is a 30%, so its probability will be 0.3. So if someone says you to find the third decile, you have to put p equal to what? 0.3. And after solving this, you will get pi of 0.3. Similarly, quartile, that means quartile means any 1/4. So first quartile means 25%. Second quartile means 50%. Say third quartile. Third quartile means what?
0.75.
0.75. Its probability is 0.75. And median, that is middle value. What is the median? Middle value, its probability is what?
0.5.
0.5. So these are important. If you can understand this, then you learn the main thing. Okay. There are 2 examples of this chapter remaining, but I afraid I cannot complete the number 6. The number 6 is a stuff have we done in 4. So 5 may be the last math for today. The time X in the month until the failure of the certain product has the PDF is this. This is a PDF of this. They have said CDF, but they didn't write how they got the CDF. So I have to verify this, how this is. So I am doing 5 by myself. Example 5. PDF is given, fx is 3x square 4 cube e to the minus x by 4 whole cube 0 less than x less than infinity. Then what is CDF? I think you know CDF is lower limit is 0 to x. Do you know? We need a dummy variable. I am taking the dummy variable is w. I actually prefer to write w because w is totally different than x and y. So we can make this clear. This is different, right? Can we write it?
Yes, sir.
Now, can anyone tell me how we can integrate? If you think you can use the UV method, you are wrong because the substitution is available. If I take w by 4 whole cube is equal to say z, then actually this is w cube. So if I differentiate, I will get 3w square dw divided by 4 cube. Can I write it? This is actually w cube by 4 cube. So I can write it. Okay. Do you understand?
Yes, sir.
Now limit also should be changed. If x equal to not x, if w equal to 0 and x, z will be 0 and x by 4 whole cube. So just continue with me. I will give this lecture sheet after completing the lecture. So x by 4 whole cube you will get, so it will be minus z dz. Can I write it? Obviously you can write. Okay, then after integration we get minus z minus 0 x by 4 whole cube. Then what can you write? Minus it will be minus x by 4 whole cube minus 1 plus it will be 0 is 1. That is 1 minus it will be minus x by 4 whole cube. This is valid for 0 less than x less than infinity and 0 otherwise. Do you understand how they have written it? Do you understand?
Yes, sir.
Now they want to find a 30th percentile. What they want to find? 30th percentile. So 30th percentile. So what is the probability of 30th percentile? 0.3. So let probability, always you have to put this to CDF, not PDF. Why do you have to put this?
Yes.
Video.
This is pi 0.3. Its probability will be 0.3. And you know this is 1 minus e to the power minus. In case of x, you have to put now pi 0.3. Whole cube is equal to 0.3. Can I write it? So after taking the side transfer, right, e to the power minus pi 0.3 by 4 whole cube is equal to 0.7. Now taking ln on both sides, e ln cancel, so minus pi 0.3 by 4 whole cube is equal to ln 0.7. Now taking root cube to both of the sides, since cubic function applies the minus sign, so we can write it 0.3 by 4. In case of root cube, minus will not have any effect. But if there is a square, definitely have there some effect. Do you understand? যদি স্কয়ার হতো তাহলে এফেক্ট করতো, কিন্তু কিউবে মাইনাস কোনো এফেক্ট নাই, অড পাওয়ারে মাইনাস এফেক্ট নাই, জানো?
Yes, sir.
So minus 4 root cube ln 0.7. You can use the calculator. What is the value? 2.84. 2.84. 2.84. Similarly, they have found 90%. So 90th percentile. So pi, we have to write pi 0.9 is equal to 0.9. In a similar manner, you can solve this. You can find 0.09 is equal to minus 4 root cube ln 1 minus 0.9 now. So it will be 0.1. And after simplifying, you will get 5.28. What you can find? 5.28. Okay. Hello.
Yes, sir.
That is the probability of 2.84 is 0.3 and probability of 5.28 is what? 0.9. তাহলে 5.28 এর প্রবাবিলিটি হচ্ছে 0.9 আর 2.84 এর প্রবাবিলিটি হচ্ছে 0.3. They have calculated another thing. The probability between 2.84 less than equal x less than equal 5.28. Though this is unnecessary
0.9
because
থেকে আসছে ওটা কি স্যার ইয়েতে লেখা আছে এক্সাম্পলে?
yes,
ওকে ওকে
but the last part is unnecessary. It's just showing we can use this, but this is not necessary. You can write f 5.28 minus f 2.84. But we know the probability of 5.28 is 0.9 and this is 0.3. But this part is not necessary for an exam. I am showing just as in a book. Okay. Only 5 minutes remaining. We have to take the attendance. So I am not continuing the last math.
The next class is exam.
Inshallah. The chapters, chapter 2 only, chapter 3 will not be included. And for your confirmation, since you have a limited time, just see the exercise. Only the exercise, okay?
Okay, sir.
I'm not giving the examples right now. But exercise will be required in your meet. Okay, I have not enough time for discussing anything.
স্যার শুধু কি এক্সারসাইজ দেখবো নাকি এক্সাম্পলস দেখবো?
Example দরকার নাই।
শুধু এক্সারসাইজ।
হুম।
আচ্ছা।
Okay, I am going to take the attendance.